Hello friends, welcome to my YouTube channel Civil Engineering Hub. In today's video we are going to learn that how we can use height of instrument method. First we are going to start with some basics, and then after we will move towards one solved example so that you can get better idea that how we can use HI method. From both the methods, rise and fall method and HI method, HI method is very easy as compared to the rise and fall method. So basically we will start with this method. In next video we will see the rise and fall method. There are two definitions, station and instrument station. Station is a point where we are holding our staff. To find the RL of that particular point on the ground where the staff is held vertically, that point is known as a station point. And the instrument from where we are taking the reading, that is known as instrument station. Let's understand this. This is a ground profile. This is our dumpy level. At this place we have kept our leveling staff. So the point where we have placed our leveling staff is known as station point, and the place where we have kept our dumpy level is known as instrument station. Next definition is a height of instrument. So if benchmark is given to us, we can easily identify the height of instrument. Say at this place where I have kept my dumpy level, the RL of that point is 100 meter. So if I just roughly keep a leveling staff near to my instrument, I can easily find out height of the instrument. So as per the definition, the elevation or the RL of line of collimation when the instrument is correctly level, it is called the height of instrument. So before finding the height of instrument, leveling of the instrument is must required by using foot screw. Before moving to the example, we need to understand these three definitions, that is backside, foresight and intermediate side. So the first reading that we are taking by using a dumpy level or any instrument is known as backside reading. Backside reading is generally taking, we are generally taking the backside reading on the benchmark to reach up to the height of instrument, right? So the first reading that we are taking by using dumpy level or theodolite is known as backside reading. Second, that is foresight reading. So the last reading that we are taking from any set of instrument is known as foresight. Now you can consider that if we are at change point 1, the first reading we will take, it is known as backside, and from the same station point the last reading that we will take is known as foresight. Again we will change our instrument station. So the first reading we will take on the previous one which we have already surveyed. So the first reading is known as backside, and from the change point to the last reading that we will take is known as foresight. Third one, that is intermediate side. So any other reading that we are taking between backside and foresight is known as intermediate side. So let's understand this by this figure. Here I have kept my instrument. First reading I am taking on the benchmark. Say this is a benchmark. This is my first reading and last reading. So the first reading that I will take on the leveling staff which is behind my instrument is known as BS. Intermediate, it means the second staff, that is known as IS, because that is intermediate side, and the last reading that I am taking from the instrument is known as FS. So in short we can understand that first reading will be BS, second reading will be IS, and last reading will be FS. Now we will see the formula by which we can calculate the height of the instrument. So the height of instrument can be calculated like the HI is equal to RL of VM plus BS reading. Suppose you are surveying on a first point and the benchmark given, that is given to us, that is 100, and on a back side you are observing reading that is 2 meter. So you can say that height of instrument is 100 plus 2, that is equal to 102 meter. Similar way, the HI remains unchanged till the instrument is shifted. It means that if your instrument station or your a survey station consists a reading of BS, IS, FS. So until FS your HI will remain same. When you are moving to the next point, you need to find the new HI of your instrument, and to find out the RL of any point, the formula is RL is equal to HI minus IS or FS, whatever the readings, that depends on the number of leveling staff station. Now as you can see in this figure, we have few readings and we have shifted our instrument two times. First, that is 3 meter, second reading is 1 meter, 4, 2 and 3 meter, and again we have shifted. So total you can say that we have 3 instrument station. Now let's identify the BS, IS and FNs among the readings. So the first reading that we are taking on the benchmark, which is given to us, that is 100 meter. So this reading is definitely going to be BS. Second reading is 1 meter. So for this instrument station, this is the last reading, because then after we are shifting our instrument. So the second reading that we have taken, that is known as FS. But on same leveling staff, after shifting the instrument, we are again taking reading on the same leveling staff. So for instrument station 2, 4 meter will be BS, 2 meter will be IS and 3 meter will be FS. Again we need to change our instrument. So the first reading that we have taken, that is known as BS, and the last reading we have taken is known as FS. Now let's solve this example by HI method, so it will be easy to understand that how we can find out RL of any point. So now we know BS, IS and FS. So after calculation of the example, you need to do arithmetic check, that is nothing but sigma BS minus sigma FS is equal to last RL minus first RL. It means the summation of BS reading minus summation of FS reading should and must be equal to the last RL minus first RL. Let's solve this example. So now we have this 5 points, that is A, B, C, D and E. So let's understand how you need to write the readings. So we have 5 stations, that is A. So for station A, the BS that we are getting, that is 3 meter. We don't have any IS for station A, but we have FS, that is 1 meter, but FS is on station B. So you can say there is no FS for A station. Now when we are moving towards point B, we have BS, that is 4 meter. We don't have any IS, but we have FS, that is 1 meter. For station C, we don't have any BS. We have IS reading, that is 2 meter, and we don't have any FS also. For station number D, we have BS, that is 2.5 meter, IS, that is nil, and FS, that is 3.0 meter. And for station E, we have the last reading of the survey, that is of course going to be the FS. So we can say we have no BS, no IS, but the FS we have, that is 2.7. Now this is how you need to prepare a table according to the given reading. And the second type of example which is generally asked in GTU exam, that is the survey is carried out on continuous sloping ground. So in that case you need to understand that when there is a continuous sloping ground, the reading above 4 meter, it is not possible, because in that example you will have one line, that is all the readings are taken with the 4 meter staff. It means maximum reading that we can take, that is up to the 4 meter. So you will observe the reading like this, that is 1 meter, 2 meter, 3 meter, 3.9 meter, and the next reading, that is 0.3. It means for one survey station we have taken 4 readings. The fifth one is change point for us. So this is how you need to understand the data. So this is 100 meter, which is already given to us benchmark. So now we have this reading, that is BS, IS and FS. So for station A we have RL, or you can say the benchmark that is given to us, that is 100 meter. First reading that is given to us, that is 3 meter. So we can say that the height of instrument that we are getting, that is 103 meter. Now we are at the 103 meter height, and on station B the Fs is 1.0. It means in from the 103, if we deduct 1 meter, we will get RL of point B. So you can say RL of point B is equal to 103 minus 1, which is equal to 102 meter. Now 102 is a RL for B station. Total reading for next station, that is 4 meter. It means again we need to find out HI. So RL is known to us, that is 102. If we add a 4 meter, we will reach up to the this height, because next reading is given to us, that is 4 meter. So we will reach somewhere here, and the new HI that we are getting, that is 106 meter. So for next two station, IS is 2 meter. So you can say that the RL of that point is 102 minus 2 meter, because for station C we have IS, that is 2 meter. So it will be 104, and for station D we have 3 meter reading. So 106 minus 3 meter, that is going to be 103 meter. Now again we are shifting our instrument, it means we need to find out new HI, and the reading of BS, that is 2.5 meter. So we want to reach up to this height. So in RL of D station, if we add 2.5 meter, the reading will be 105.5 meter, and last reading which is given to us, that is 2.7 meter. So from new height of instrument that we have calculated, that is 105.5, if we deduct 2.7, the answer will be 102.8. So now we have calculated the entire example, and for arithmetic check you can prepare this kind of table. That is, here you can see on the left side RL of column, last RL is 102.8 minus first RL, that is 100. So the difference is 2.8. Sigma BS minus sigma FS is also 2.8 meters. So all the readings and calculations are right. So this is how you can calculate example by using HI method. Thanks for watching this video. If you like this video, please share with your friends and subscribe to my YouTube channel Civil Engineering Hub. Thanks for watching.